Hello. Today we're going to talk about three different motions. So we have constant velocity motion. And then we have constant acceleration motion. And then we have constant speed motion. Okay. So constant velocity motion first, right? So first one, so 1, 2, 3, right? So constant velocity motion. So we're going to assume that we are moving in a straight line. So constant velocity motion implies that this car here is moving with a velocity vector. Let's say it's going to the right now. So it's positive, right? So it's positive. And it's always have that same velocity, right? So it's moving forever. So that's constant velocity. So in this case, the displacement, right? So the displacement x is equal to v times the t, right? We assume the t0 is equal to 0. Right? So then that's your displacement, right? Vector. And this is your velocity vector, right? So velocity here, it's a velocity vector, right? And t is a scalar. Okay, so and acceleration in this case, because velocity is the same, acceleration is equal to delta v, delta t, and delta v is 0 because v is constant. So that's equal to 0 divided by delta t. So a is 0. So a is the acceleration vector. Okay, right. So you can be going to the left also, right? So in that case, your v is going to the left. So then your v is less than 0, but still, it's always that, another v here, but that's also less than 0, but v is still constant, right? Okay, so that's the constant velocity motion, right? So we're going to talk about constant acceleration motion. So constant acceleration motion, we're going to concentrate on one dimension also. So you have this car here, and let's say the velocity right now is 0. And he's moving, but he has a gas pedal, he presses on it, so he starts accelerating, right? So at time, there's a later time, this v now is different, right? It's not 0 anymore. So this v is equal to 0, right? Because v0 is 0. So v0 is 0 plus the acceleration, right? So this is 2, right? Constant acceleration, right? Motion, right? Times at, okay? So that's your velocity, and it's not constant anymore, but it's changing due to this here is constant, right? It's constant, right? Okay, so then you can calculate if you know the time, right? So for example, if time equal to 1, right? So we assume t0 is 0, right? So time equal to 1, and let's say acceleration, let's say, is equal to 10, right? So then you know your v at time equal to 1 will be equal to 10 times 1, and that's equal to 10 meters per second, right? So you know it's increasing, right? So if we want to plot the v versus t in this case, right, it will be starting from here, and it will be going up like that, right? And then the slope here, right? So the slope here, okay? So let's say this is delta t, this is delta v, right? So this delta v versus delta t is the slope. And that slope is equal to acceleration's magnitude, right? Okay? And in this case, if you are speeding up going to the right, then you know your a is larger than 0, right? Okay, so usually we assume going to this direction is positive, right? So this is positive x going this way. Okay, so that's a constant acceleration motion. And then in this case, the displacement is equal to v0t, and that's drop out, right? And there's an x0, which also drop out, because we assume x0 is equal to v0 is equal to 0, and t0 is also equal to 0, right? So we assume that. So then this is equal to x0, 0, plus v0, which is 0, plus is become 1/2 at squared, okay? So then it will be 1/2 times 10, and let's say we want to find out at time equal to 1 also. So times 1 squared. So then that will be equal to 5, right? So 5 meters. So that's your displacement, right? So this is the displacement, x, t equal to 1 is equal to 5 meters, right? And it's going to the right, okay? I mean, it's going to the right. Your displacement is going to the right because your displacement goes like this, right? So initially you are right there. So your x0 is 0, right? And later you are here. So your x1 is equal to 5, right? So really your delta x, which is the displacement, is equal to x1 minus x0, which is equal to 5. And sometimes they are lazy, they want to call this to be x, okay? So because x0 is 0, right? So then, but you know that your displacement actually is like this. It's from here and going to here. So that's your displacement vector, and it's going to the right. So this phi has a direction. The direction is going to the right. Okay? All right, so number 3, we're going to talk about constant velocity. So constant velocity, I mean constant speed, okay? Number 3, constant speed. So you got to be careful with this one. Constant speed motion. That's different from constant velocity, okay? So we don't talk too much about this in this chapter, but in chapter 5 we will. So if you have something that's moving around a circle, like a car driving around a circle, okay? So your speed can be the same. Your speed, right? Your speed 1 is equal to 10 meters per second. And your speed 2 here is equal to 10 meters per second. But it's not velocity, okay? And your speed 3 is right there, and is equal to 10 meters per second. Only the speed is constant, okay? But your direction is changing, right? So your direction of velocity is changing constantly. Changing constantly, right? But your magnitude of velocity, which is the speed, right, is equal to constant, okay? So that's your constant speed motion. And I'm going to stop there, okay? Have a great one, okay? Until next time, bye-bye.